Good morning, class. Today is our last lecture for the year 2025. So the next time we meet, it will be 2026. So may I wish you all a Merry Christmas and Happy New Year in advance, and hope you have a good holiday after today's lecture. Today we are going to look at an interesting topic, which is Boolean operations in FreeCAD part workbench. Boolean operations in FreeCAD part workbench. You have received the slides already, I hope, even though the version that we are looking at now is a little bit more up to date. I can send this one after today's class, but I thought it was good to at least for you to have something to work with. This slide has about 36 pages. The one I sent to you will be like around 30 pages. So there are 6 more slides here. That is 1. 2, because I've reviewed the slides in the past 24 hours, I've been able to correct some of my mistakes on those slides. The ones we discover during this lecture and the one I discover afterwards will be affected, changed before you receive any other thing for this lecture. So the topic is Boolean operations in FreeCAD part workbench. We have specific goals for today's lecture. So by the end of the lecture, you should come back to this slide and check all the things that have been done effectively in your own understanding. I want you to be able to create graphics using the graphical user interface, GUI. So when we say GUI, we mean the graphical user interface. That's what you're already used to, where you just take an icon, create a line, create a circle, create a rectangle, make a box, do a revolve, all those things you are doing in the graphical user interface. We will also now use the applications programmers interface, API. So the API and the GUI are 2 different windows to the same engine. Whether you use the API or you use the GUI, you are actually, the instructions the computer receives is exactly the same. So if you tell the computer to create a circle using GUI, and you tell the computer to create a circle using API, what the engine receives is exactly the same instruction. So the result will be the same. We also want to learn the Python structure of the FreeCAD API. The FreeCAD API has a Python structure, even though the API itself was written in C++, but it has been wrapped inside Python to make it easier, because it is assumed that C++ is a very tough programming environment. Well, I think in C++, and I can understand. I actually enjoy programming in Python, but I can see very clearly some of the watered down versions of the classes and things that you could achieve in C++. But to make up for that, Python is far more expressive and it has a large library. So you are getting the best of 2 worlds in being able to program the API using C++. In some other programming environments, you have the option of programming in C++. Like in Fusion, you could program in Python or C++ as you choose. In FreeCAD, you can only program in Python. So we want to look at the basic Python structure of the FreeCAD API, because there's no other structure, and understand what to look for. You'll be able to create graphics iteratively. You'll be able to compose graphical collections, like a list of graphical objects, and so on. The third thing we want to achieve today is for us to ring it in you to know that there is a difference between geometrical and graphical entities. They look the same and they can be confusing. The fact that they are different can be confusing. But it is good for you to begin to use the API. You must know what the difference is. You must know when you have only given an idea to the computer, but you have not yet instructed it to create something. It is worth it to give an idea. Oh, there's a town called Lokoja somewhere in Kogi State. You can be saying that. It's a completely different thing to enter a vehicle and travel to Lokoja and be in Lokoja. You can see Lokoja in the video. You can have an idea of where it is. You can know the geography without actually, the person who is actually physically in Lokoja is in a different realm as far as Lokoja is concerned. So that is the difference between a geometric abstract entity and a graphical visual entity. They use the same things. They just use different words to express the same things, but they are completely different ideas. And it is important for you to understand the difference between abstract and visual objects. Number 4, I want you to be able programmatically to access and query active documents and objects. So there's an active document which somebody has created, whether he created it in GUI or he created it in API. Can you write a program that can talk to that graphical element? Can say, okay, look, I want you to rotate. And you are not using your mouse, you are just writing a program, and as you are running your macro, the things you want to happen are happening because you are accessing and querying active documents and the objects they contain. We will then be able to show you how to work in hybrid workbench via Python scripting. Right now, most of what we have done has been in the part design workbench. Sometimes it is easier to work in the part workbench, but the two workbenches do different things. So how can you work in one and use the facilities in the other? That is the hybrid workbench that I am talking about. You'll be able to see what can be done, how you can do it, and how much power you can get from that. Very often when you are using the API, my experience is that the classes in the part workbench are actually more accessible than the ones in the GUI. It seems than the one in the part design. It seems as if the part design is created primarily for the GUI, whereas the part workbench is much more effective in the API. This is just my own surmising. I don't have sufficient experience to make that statement categorically, but that's how I feel. You will see why I feel so in today's class. The last thing we're going to try to achieve today, we're going to go through some Boolean operations with the practical example of mold making. And we will make concrete uses of these abstract constructs. Oh, you've been hearing of intersection, union, subtraction, addition, and something of sets. Sets are abstract concepts. So we want to come now to real concrete concepts like, and when you talk of intersection of two sets, suppose two solids are intersecting. What is the union of those two solids? What is the intersection of those two solids? What is the subtraction of two solids? We are no longer talking of an abstract set. We are talking of a physical thing you can see, and they are intersecting. You can see they are intersecting. And you want to now calculate all those Boolean operations from them. And those Boolean computations are extremely useful and have practical consequences. I want to show you how those things happen. One of you was telling me to recommend YouTube channels that you can use. You said the YouTube channel you can use, but I am sure by the time we do one or two more lectures, you will see that our class is not something that you can replicate from a YouTube channel. They're usually because the YouTube channel are designed to teach the person in the motor park or anybody who can just pick up a computer. I am not making fun of that. I'm just saying that I am looking at you not as just somebody in the motor park or somebody who has no background. I know you are engineers, you know geometry, you know calculus, you know algebra, you know vector. So there are some things that I am going to talk about that somebody who is just creating a video for the general public dares not go to. Therefore, we should be able to achieve higher goals. We should be able to, what we should end up with should be far superior than from what you can get from a YouTube channel. But that doesn't say that you cannot have some specific things that it can teach you. There may be a skill to create a particular entity that a YouTube channel can help you to do. But YouTube channel cannot be your answer to this class. Your answer to this class is please do your homework assignments, find any help you can find. Use AI if you have access to one. I use AI a lot. So if you use AI, that is encouraged. AI cannot solve your problems completely. AI can't replace you, but it can help you The more you know, the more you can gain from AI. The less you know, the more useless AI is to you. So creating graphics with GUI API. So as one of their goals is the ability to do such graphics, we look at the fact that the Fusion API, for instance, I always talk about Fusion because I am coming from the Fusion environment. The Fusion API and the GUI are designed to be equivalent pathways to the Windows equivalent pathways and windows into the drawing engine. So there is scarcely anything I can create in the API of Fusion that cannot create in the GUI. In FreeCAD, things can be somewhat different. There are sometimes the GUI is not as powerful as the API, and that shows up in some things. I have had some things that I wanted to do in a FreeCAD, and the only way I could get them done is to write a code. The GUI was not enough. Now, it is arguable that it's because I don't know enough of the GUI. So I don't want to make conclusions on that. Maybe when I know more about the GUI myself, I will reach different conclusions. But I will tell you, I am sure the power of the two are not the same. Also, you have workbenches with different powers. The things you can do with the part design workbench are not the same as the things you can do with the part workbench. And the assumptions in one workbench will be different from the other. That is what you get when you are using a free open source operating system design program, because there is no company that is forcing everybody to speak the same language. So the teams that are developing these things sometimes work in parallel, and that shows up in the way those things really move. So there are some things you can do with one, you can't do with the other. For example, if you have two intersecting solids in the path workbench, there are two intersecting solids, which is not a reflection of reality because two solids cannot intersect in real life. But if you see those things in the part design workbench, automatically the union, the Boolean union of the two of them is what you will get. So if you have a solid that is completely immersed in another solid, it is only the external solid that will remain. The outside solid will consume the whole one internally. Whereas if you are dealing with the part workbench, the two of them will remain extant and you can address one or the other. So that, and you will see as the time goes on today, that there are some useful things about one way of looking at this and the other way. Because in the part workbench, you can now decide to take a union if you want. But apart from a union, you can decide to take an intersection if you want. You can decide to take a subtraction, which is a cut. But if you want to take a subtraction, then one of them has to be defined as the base, and the other one has to be defined as the tool. So if you have A minus B, you are cutting B from A. A in that case is the base and B is the tool. If you have B minus A, then B becomes the base and A becomes the tool. We'll see some of this later on. But the conclusion is that the API can sometimes achieve things that are difficult in the GUI. A good Python programmer may achieve better results than a GUI user, even better than what you can achieve in Fusion. That now becomes possible. Then we will look at collection classes. When I was giving you some tutorial on Python, I introduced collection classes. I don't know whether you remember them. For instance, a list is a collection class. A set is another collection class. A dictionary is a collection class. A tuple is a collection class. Then you can have a set of lists. You can have a collection of collections. After all, a state in Nigeria is a collection of local governments. But the nation itself is a collection of states. So you can have Nigeria, which is a collection of states, which is also a collection of local governments. And a local government is the collection of towns and villages. So you can have collections of collections of collections. So that's real. That's real and practical. So you can have collection of collections. So we looked at a number of constructs, a number of Python constructs we previously learned with trivial examples. When we are doing those things, when we are looking at sets. We are looking at sets of Nobel laureates. We only had string constants because we just had the names of the people. That's what we had. We can look at set of we can take a sentence and look at the set of words that make up the sentence. Again, that's still a set of constant strings. And we can just look at the grades you scored last year. It's a set of numbers. All those ones are simple things. Uh, what happens is that when we get to FreeCAD, some of the things we learned, some of the constructs we learned with trivial examples will come alive with robust practical constructs that have much more practical uses. FreeCAD easily become the input-output to our programming. So we shall encounter comprehensions in lists, in sets, and dictionaries. We will see tuples of various kinds for iteration. Our examples up to now were trivial, not what numbers or string constants. We will see more interesting objects like graphical entities, geometrical specifications, combination of dissimilar elements like radius and location. For instance, if we are talking about a circle, just take an example of a circle. Can you tell me how many things you will need to know about a circle? Let's go to the chat room. Tell me how many things do you need to know if you are talking about a circle? What are the important things to know about a circle? Tell me the important things to know about a circle. No, don't just say one. Just tell me this. Just I want to see. I want you to show me what are the things. If somebody wants, if you want to tell somebody to give you a circle, what will you tell him about the circle so that he will be able to give you the circle? Okay. Well, the circumference and the diameter are the same information. Okay, radius, circumference, area, and diameter. Radius, circumference, area, and diameter. All the things you have listed, the same one thing, because you can get the circumference from the radius, you can get the area from the radius, you can radius, circumference, and area. That's still the same thing. Center, aha. Center is a different idea. Radius, diameter, and circumference are the same information. Area is the same information as the radius. The arc, yes, the person talking about the arc. For instance, you may not want to draw the circle in full. You may want to do only 200 degrees of it. Okay, so radius, center, plane. Okay, to be sure that you have mentioned something that is important. On what plane is the so you need to know the radius, you need to know the center, you need to know the plane. Okay, those are three things. So you also somebody talked about the arc. Somebody talked about the arc. So we can say radius, center. No, tangency. You don't need to know the tangency. So we have seen. So you can see. So if I want to pack a list with circles, so each point in that list is four tuples. The center, the coordinates of the radius, how big whether the circle will take the whole 360 degrees or will take only 10 degrees, and what is the orientation of the circle. What is the normal to the circle? So you can see every circle is a tuple. So if I have a list of circles, I'm having a list of tuples. So you can see that it becomes more interesting. And if I now pass that on to, if I pass that on to the FreeCAD GUI or FreeCAD engine, it can give me several circles as a result of that. So you can see that we are now beginning to use these things in a far more concretized way than we were doing before. So that is the thing. So when we use FreeCAD as our input output in our programming, we can achieve things that we can understand the Python language much more than we did before. So we can have comprehensions. We can have it in lists, we can have it in sets, we can have it in dictionaries. We can have tuples of various kinds. We can iterate using our tuple. Our examples up to now were trivial. numbers and string constants. You can see just introducing a graphical object. You can see how interesting things become. You may say how difficult, but they are not difficult. They just become more interesting. Here we will have more interesting objects like graphical entities, geometrical specifications, combination of dissimilar elements like radius, location, etc. We will also look at methods. Instantiations will be used to do things that are visually observable. For instance, if I have a method and the method say make ellipse, so I said make ellipse. If that method successfully made an ellipse, you will see the ellipse. If you cannot see the ellipse, then probably the ellipse was not made, or you don't know how to make an ellipse. So if there's something that says make a box, that box you should see, but you would have given specifications of what that box should look like, where it should be located, how big it should be, and what orientation, and so many other things that you must supply in order for that to happen. And if you are supplying that in a collection, you will see that it will be now a collection of non-trivial items that actually have visual, that are visually observable. And because of that, you will understand Python more. So when you are in this class, there are at least 3 courses you are taking in this class. You are taking a course in Python. I'm sure some of you would have realized that now. You are taking a course in graphics. You are also taking a course in design. And that design means you are doing strength of materials. If you're already into your strength of materials, you will be surprised that in this course, you can actually query some of the things you are doing in your strength of materials, and you can do them better, and you can get results of more practical examples than your strength of materials can do. Because actually, if the timetable, if those of us who plan the courses actually know enough of some of these things, some courses would have become obsolete by now. And you will see, I will take strength of material as one example. And not everything about it, but this one can be used to augment it. Okay, so let us move on. So we talked about collection classes. Okay, so geometrical and graphical entities. You will see that geometrical and graphical entities will be used with nuances. They are related but not the same. The differences will determine whether or not your well-constructed geometry will be seen. And in this case, let me ask some questions. If I said draw a line, can you tell me what the thickness of a line really is? I want us to go to the chat room. Tell me what is the thickness of a line? If I ask you, draw a line, what is the thickness of that line? What is the thickness of a line? Chat room. If I give you a line, I give you the gradient, I give you the equation of a line. Say y is equal to 3x plus 5. Now, if I tell you to draw the line, how long is the line? What color is the line? How thick is the line? Can you tell me? Okay, it depends on the tools used. Okay, that is Oluwafemi. Oluwafemi. Anybody else? What about the color of the line? What are the beginning point and end points of the line? You can see, I have asked you these questions to show you that a line is not a defined concrete entity. It's an abstract concept. A line has a thickness of 0. So if I drew that kind of line, you can't see it. by the time I draw a physical line, it has certain things in common with the abstract line, but they are not the same. So when you are in a graphical environment, you are drawing a real line that has a thickness, that has a color, that has a presentation. It could be a construction line, which is dash, dash, dash. It could be a real line, which is continuous. It can have a beginning and can have an end, can have a length, can have an orientation. So what I'm just telling you is that the abstract concept of the geometrical idea of a line is different from a line that will be displayed. The line that will be displayed on your screen with picture pixels. So it will have to have certain concrete things that are not part of the definition of the abstract line. So because of that, there are things which give us the geometric concept, and there are also things which give us the actual line that we can actually display on the screen, and they are different. So you see how we can connect a drawing you have made and add more power by calling active entities. One of the things we will do, not only are we going to create graphical entities that are specific, we will also show you how to query entities that have been previously made. You can make new entities with your API, but you can also look at the entities that have already been created on the object tree and do things with them. So that is, and then we can give names to the entities on the object tree. We can use name to introduce some of those entities into our macro scripts. Practical examples. We introduced 3 practical examples of the API and Boolean operations in today's lecture. Actually, the 3rd example will come in the next lecture. We don't have enough time to go through it. 2 are industrial problems in mold making. The 3rd is in turbo machinery. The one in turbo machinery will come later, but the 2 in the mold making will come today. If you are told to design a mold by a casting company, those that make engines or plastic objects such as toys, how will you go about that? The answer is in Boolean operations. We will show the examples first, look at some basic theory, and work out our examples. You remember this object, the object we started with. I don't know whether it is clear to you. It is at the background of this page. We saw there is just is a three-armed element with grooves, and it also has slots. Initially, it looked difficult, but I am assuming that most of you have created it by now. I'm sure some of you have successfully made it. So another problem, how do you manufacture it? Suppose you actually want to make one specimen. Oh, of course, you can send it to 3D printing if you have a 3D printer. So you can do 3D printing in low quantities. What if 1 million of it is needed? At that point, 3D printing will not work. You need an injection molder or some high volume method. And the first thing you need, an injection molder will need, is a mold. How do you make a mold? Can you design a mold? Yes, you can design a mold. So let us create a mold for this object. We take a drawing now. We look at the sketcher. We take a sketcher in the XY coordinates of a sketcher. So when we look at that thing from the top, that's how it looks like. So we want to create a mold base. The mold is in some ceramic or earthen clay that have been hollowed out in the shape of the material to be made. In photography, this will be a negative, and the object itself will be a positive. It is difficult to make this directly in the part workbench, because if you make 2 solids and one enters the other, the part design workbench is going to make them into one, and one will subsume the other. So how do you then make this negative? Step 1, start with the base that contains the mold. So in this case, we are deciding to do a box. We want to do a box that engulfs it. Start with the base that contains the mold. That base most fully contain the mold. In set theory, it is a superset of the positive. Look at this example. Begin with this sketch. We'll begin with the sketch, and in the sketch, we have these exact dimensions over the material we had before. When we finish padding it And what I did here is to give some transparency value or opacity value to the base so that you can see what is inside. So that's why we can see that. So we create a positive rectangular pad and it is B minus A. So let us say the base minus the positive. And that is the same thing as the union of B and A, subtracting the intersection of B and A. When you have a situation where B, from set theory, if B is totally containing A, the B union A is simply B, and the B intersection A is simply A. So B minus A will just be B minus A because B union A is B, B intersection A is A. So we can use a Python code to achieve this, as shown in the next slide. I hope you are able to download the code, which I have there. That is the path to the code. I was disappointed last week when not one student tried the code I gave. People were giving excuses. I hope things are different today. I hope you have done, I hope more of you would have tried out some of the codes. But today, because I don't want to waste my time, I'm going to give you some of the codes to download. But if you do not type this thing in yourself sometimes, you do not learn much. So I will leave that to you. So it is for you to know what is good for you. If you like to learn, learn. But I'm not giving you all the codes, but I will probably give you like 4 or 5 codes today, or 6, 4, 5 or 6 codes that you can download and run. But don't just download and run. We are going to examine these codes and see that you gain sufficient understanding of the codes. So let us say you will now have the name of the macro is called groove mold. The drawing has the base as part 001 and the final state is called the groove. Lines 13, 14, and 15 in the code in the sets the base as the pad, which has already been linked to the object pad 001 in line 6. So if you look at the fact that in line 6, the identifier pad is connected with the object pad 001 on your GUI. This is how we do it. You get that, you collect that from the active document. So this is all you need to do. So this is the name that you can see on the this is the name you can see on the GUI object tree. But inside the program, this is the name that the thing will be bearing. Pad is linked to pad 001. Similarly, groove is linked to the GROOVE, depending on whether these are the names you gave. If you gave different names when you did the drawing, the only things you need to change are these names to the, for instance, we should have just constructed part 001, and then the groove was the thing we had in the old code. So when that has been done, what you are going to do here, there are 3 lines. You are going to, once you just say you are going to create a mold, and you are going to add a physical object, and you are going to do a cut from the part workbench. That's what the first element here is telling you, that is a cut. A cut is equivalent to subtract. And then the name that will be given to the result is mold. Anything you put here will be the name that will be given to the result. So, but if you are subtracting, you have to define one as the base and the other one as the tool. Here, the part that is covering everything is called the base, and the tool is the groove. So if you cut the groove out of the pad, you are now going to have a negative groove inside the pad. So that will be a cavity that can be used for this thing. And then once you do that, the coding is finished. And I will just continue after the video. So you can watch those videos. We can watch that video clip, which is about 6 minutes on your own, because it's already in the slides. I'm surprised that I can't get it done like this. So let me continue with my slideshow from the current slide. So I'll go to the next slide now. Okay, so in the next slide, what I was asking you to do is to just modify the code that we have just used and use a cylinder object instead of something. I just change the code a little bit to create the mold using a cylindrical base. Use a cylindrical base. This is the same thing we did for the groove that we are now doing for the Mobius. You can do that for any object. And what you need to do in the code here, the things you need to change are the names. So you have to check the names that the part that engulfs it, which is a cylinder in this case, what name you give it. And then instead of groove here, you are now going to put something like Mobius object. So in the first 7 lines of the code, they are close to stuff you'll be repeating most of the time you write Python code. So you better know what those things mean. So there is the first few lines, you are just going to have your import libraries. Sometimes when you import FreeCAD as app, what you are saying is that from that point on, the FreeCAD there will be referred to as app. And then you now check, you now say doc is equal to active document. This particular file assumes that there's an active document. It will fail if there's no active document. And so you have to be careful there's an active document unless you are going to get some errors. And then you are grabbing the part 001 and the groove. But if you don't have part 001 on your object tree, if it is part 002 or some other name, or if it is a Mobius, you do that. And then you just follow the same rule that it just by the time you change two or three things on the other code, it will run and create the same mode here. So the things to do to make that happen are already given to you here. Now, preempting errors. This one, if pad is none or groove is none, uh, none is a binary, is a Boolean and is binary. None, just like true or false, there is none and not none. Now, when will pad be none? What is pad and when will it be none? I want to go to the chat room. Tell me, the line 9 here is saying if pad is none or groove is none. When will pad be none or when will groove be none? I want you to tell me in the chat room. When will pad be none and when will groove be none? Yes, I see what you said, Oloketuyi. I'm not satisfied with that answer. Let's see what the others would say. When will pad be none and when will groove be none? I want a better answer than there's an effort by Oloketuyi. Let's see whether there are other people that have tried. I'm not hearing anything. When the pad or groove wasn't created. Well, yes, but not completely. Remember, let us look at the last statement. You can see that in the last statement, we assigned pad to the object pad 001. It is when pad 001 does not exist. That is when pad will be none. You see, because here, pad is just an identifier that is linked to pad 001 in the GUI. So if pad 001 has not been created, pad will be none. If you made a mistake in the spelling of pad 001, let us say you typed small case pad, or whether your drawing has become pad 002 and or you just made some mistake there. So it is either that it hasn't been created or it is not correctly referenced. So those are the conditions. Okay. So those are the conditions. But why? What are the others doing? Why are they sleeping? Where there's an invalid sketch, that is possible when the pad does not exist or the groove does not exist. So that is the meaning of when the pad is none or the groove is none. So what is the opposite of none? Can somebody tell me? Because if it is true, the opposite is false. If it is not true, if it is true, the opposite is false. If it is false, the opposite is true. What is the opposite of none? The opposite of none is not valid. The opposite of none is not none. That is in Python, the opposite of none is not none. Two words, not none. And they are keywords. So if the pad is none, that is the pad doesn't exist. If the pad is not none, that means that the pad exists. Okay, so the opposite of none is not valid, is not any other thing, but not none. So you can see again, we can continue, and you can see that in this place, you can see that the what we have going to do is that you are going to do a path cut, and you are going to define the base as the pad and the mold as the tool. Essentially, the programming is finished. The other things you do after now are just clean up and standard stuff. So that code is going to cut out your groove for you. So let us look at another example. Another example, we look at the part workbench with Boolean operations. Here, you can go to the part workbench and create two part primitives. One of them is a torus. This one, I created this one with the default values, and I created this sphere again with default values. The only thing I did is that I used the data editor. If you mark the sphere and you allow the x coordinate of it to become 10, this is what you get. And apart from that, I didn't do anything. I didn't do anything else. So I got this. Here you have two bodies that intersect. If this were a part design, the workbench will automatically create a union so that there will be no ambiguity as to what part owns what. In part workbench, it is left to you to do what you like with this. All your set operations can be used in this case. On the next slide, I will do cuts, intersection, and subtraction. It is a good practice to try this out. You can try this out. You can see that if you try this out, these are the part. If you try to do cut on this, to do intersection and to do subtraction, you get things like this. For instance, if you do a subtraction and you use the torus as the base and the sphere as the tool, this is what you get. So the sphere is the removal of their common intersection. The torus minus sphere is the removal of their common intersection. So in FreeCAD, intersection is called common, and there is a method to create intersection. So what is common to them? You can see that this part is common to both is part of the torus and it's also part of the sphere. So it is called the intersection or the commonality or the common. The sphere minus the torus, if you use the sphere as the base and you use the torus as the tool, this is what you get. So this is the sphere minus torus. This is the torus minus the sphere. You can see that torus minus sphere is not the same thing as sphere minus torus. And the common thing between them is this element here that is inside the sphere and is also part of the torus. So you can see that from this page, some of the ideas of set theory becomes very, very, very concrete. You can see those things concretely in a way that you never saw them in your set theory. So this is the intersection, this is the subtraction, and this is also the subtraction depending on what you are using as the tool and what you are using at the base. To further illustrate basic graphical Boolean operations, we spend the rest of this lecture looking at some more code. We're going to look at some more code from this time on. So before we go into that, I think because our time is now at 10:55, I want you to go on break. But if you are able to go to your chat room and you want to ask questions, I'll be there and I can answer questions that you may have into this or other lectures or comments. I'll view them. So you can go to the chat room if you want. Okay, break time is over. So we are looking at the code now. In these codes, we are creating two objects. The first one, we call it a lofted solid, because in the lofted solid, we are just going to create three circles on the y-axis, and we're going to loft, we're going to create a lofted solid through them. And then we do another one, which will be a small box at the origin with small specified coordinates. So the first code does the lofted solid, and that if you have downloaded and run it, you will see this code that I have here on this page. And like as before, the first two lines are about import, the import this import. The next four lines is about checking whether there's an active document. If there's no active document, it can create one, and it will call that active document lofted solid. That will be the name of the active document if you did not have one. If you had one already, it's going to use the active document that you have, and it's going to call that one a doc. So the first thing you will see in this, after that preamble, is what you will see in the packing of a list. Uh, I want you to tell me how many elements are in that list. The list that you can see now on lines 9 to 14. How many things are in the list? Chat room, please. How many things are in that list? Okay, there are three vectors. There are three, no, the things that are there, it's not just three app vectors. There are three tuples. One is a number, and then there is an app vector. The second one is a number and an app vector. The third one is a number and an app vector. So what you have there are three tuples. One is a number, the other one is a vector. So those two combined become one tuple. There are three tuples. The first one gives you the radius of the circle you want to create, and the second one gives you the location of the center of the circle. So you can see that the center of the circle are located at point 0 along Z, point 10 along Z, and point 20 along Z, as you can see. So the next thing I want to ask is that the method that creates a viewable circle in this case, we pass three things to it. We pass radius, we pass center, and we pass another app vector. What is that third thing? The method that creates viewable circle had two parameters when we are listing them. And then what do you think this one is doing? This one, for each circle, we are creating the same. If you know what this is doing, please tell me in the chat room. What do you think this is doing? You have a radius, you have a center, which is an app vector. You have another app vector, which is a unit vector pointed in what direction? And what do you think that is doing? Yes, pointed in the Z direction. What is it doing for each circle? What is it doing for each circle? Yes, you don't know. Yeah, does anybody know? So it is telling that each circle will have its normal in the Z direction. So it is not just that the center will be in the Z direction, the center will be moving, the circle will be a circle in the XY plane because the XY plane is the plane in the Z direction. So that is it. So what you can do, if you change that vector a little bit, you will see that the circle will be disoriented. The orientation of the circle is here. If you change it a little bit, you will get circles that are not oriented in that direction. So let us say you put 0.05 here. You will see that it will tilt the orientation of the circle a little bit. That is what it is doing. The next question I have is that can you explain what is happening on line 29? Line 29 is a comprehension. Line 29 is a comprehension, and the comprehension, it will go to circles because circles now contains the physical circles that have been created. It will take them one by one and call each one a circle, and it will now pack the wires. It will pack the wires list with circle shape. So it will take the first circle, it will put the circle shape there. It will take the second circle, it will put the circle shape there. So the wires are the circle shapes, the shape object of the circles. And once that is done, he's going to pass the wires to the make loft. So the make loft, the first thing it has is wires, which are cut from here. There are 3 of them. And then the second thing is telling it whether it's a solid or not, whether it is ruled or not, whether it's closed or not. So one thing I advise you to do, after you have run this program successfully, you change this to false and see what will happen. And so this is this what you have on line 29 is called a list comprehension. And the question here is that apart from list comprehensions, what other kinds of comprehension do you think you can get? This is a way you could have done this thing by using a for loop. So I will give you a homework to try and achieve the same thing that you achieve in a list comprehension. You can go back to the notes I gave you when I was teaching you, giving you a Python tutorial, how else you can compose the thing that the list comprehension composes using a for loop. So that is what you can see here. So you can go on. The solid bar is even simpler. In the case of the solid bar, you are using the method make box. In the make box method, you are choosing the dimensions of the solid box 5, 5, 5. So that means that 5 in the x-axis, 5 in the y-axis, 5 in the z-axis, and it's going to put the corner, a toe of that thing at 0, 0, 0. So that is the way to make a box. So if you do this, a box will appear on your document, and when you finish creating it and you want to add it to the object tree, the name that will be given is whatever you see here. What this second value here is the name that will show up on the. This is the name that will show up on the something. The recompute is something that ensures that everything has been, it's like a refresh. It's like a screen refresh, because in case there are other extraneous things that have happened or something didn't show up, it will go back and make sure that everything before that is recalculated again, so that so you do, FreeCAD is the third code here does Boolean operations. The Boolean operations can be seen on, let me see where the Boolean operations, for instance, there's a Boolean operation of intersection in line 18, and there's another Boolean operation of cutting in line 22. So you can see, you can do more Boolean operations and you will see what those Boolean operations give you. So those are things that will happen here. Just run this code and make changes on it, as I've said, and see what will happen. You can change your wires and do a different loft. That is how you learn how to program. So if you check what these things do, and you'll be able to do your programming that way. So let us see what happens next. Now, I just explained what is happening here. Let me just go back to the lofted solid. I'm just saying here that in the lofted solid, you see that in lines 10 to 14, we packed the coordinates of the circle, which we call circles data, into the program. That does not create circles. It only gives an idea of what the circles will look like. It is from lines 18 to 22 we actually create the circles. And you'll see that the information we have in lines 10 to 14 are now used in lines 18 to 22. So these are the geometric information about the circle, which are abstract, and these are concrete informations about pieces of information about how the circle will be created, and the circles are created from lines 18 to 22. I just want you to notice the difference between abstract information and concrete information that actually create your objects. So where am I now? So you can see there's a difference between the three circles and the three wires. What's actually created are the three wires. And so somehow we just have some different names. For instance, instead of a point, you have a vertex. Instead of a line, you have an edge. An edge is a line that actually appears in your as drawing entities in your FreeCAD. A line is an idea of what the line will look like, but the edge is a specific line. Okay. So if you look at the what is created, it will look like this. Here you have the three wires, and you can see that they are created, and they are created with their normal going in the vertical direction, each one of them. If you change that vector, that second vector in the make make circle vector, you will see that the number here will change, and these wires would have a different orientation, and it will affect the solid, the lofted solid that you create. The next on the next page we see, okay, suppose you used solid is equal to false. If you did that, the process will create a surface instead of a solid. Here is the result of that choice. The wires are still created all the same. Instead of creating a solid, FreeCAD will make a surface as shown here. See the effort to create one from the programmer's point of view is almost the same. Good exercise to try. So you can change solid is equal to true to solid is equal to false, and you will see that you will get something else. So when you now, after that, when you create the box, it's a small box. This is what you get. The box is at the tail of the lofted solid, but they are entering each other, they are intersecting each other. So again, you will see now that you are able to do some Boolean operations here. And you can cut the lofted solid. If you want to cut the lofted solid, this is the code. The full code is on the third code that I gave you. So, but this is the engine. This is the part of it that does you can see that the intersection itself is created by the common member function, the common method. The solid box shape common is what. So if the intersection is solid box shape common with lofted solid shape. So solid box lofted with solid shape. And you can see in this particular case, it does not matter whether you say lofted solid shape common with solid box shape. You get the same result. But when it is a cutting, when it's a cutting, the first thing you use like that. If you say lofted solid shape cut solid box shape, it is going to be different from solid box shape cut lofted solid shape, because A minus B is not the same thing as B minus A. But A plus B is the same thing as B plus A. So that is the union, the intersection is different from the cutting. Okay, so these are the results. The first one is the intersection, which is the common. The second one is the remnant. You should try this out and see these things yourself on your own computer. So the union can also be done. In the case of union, the function is fuse. The function for union is fuse. If you say solid box fuse lofted solid, then it will happen like that, provided Solid box is your identifier. Here, it depends on what identifiers you are using. This is my own. So your own must be consistent, otherwise you are going to receive error messages. So I conclude by trying to explain what is the difference between part and part design. Your creations follow a hierarchy in whether you are a part or part design. FreeCAD ensures that the last entity has the results of your, if you are using part design, has the result of all your previous action and creates a final object. If there are intersects, this object creates a union in FreeCAD and in part design when possible to ensure a single component that has the correct representation for further work. In part workbench, your objects are largely on their own until you do the arithmetic you desire with them. How then are we able to create extrusion castings we started this lecture with? We constructed two elaborate objects in the past 2 weeks. We worked in the part design workbench and got our object tree in the final results in each case. When we created the rectangular and cylindrical parts, the final object consumed everything because all we had was contained inside of it. But we wanted more. We wanted an extrusion mode. How did we get it? So we need to know the way we got it is that we use the part design and we part workbench. When you use the part workbench, you can do your Boolean uh, processes. And it's important for you to know that there are different, there's an object hierarchy. There's a line, which is different from a wire, which is different from a face, which is different from a solid. A point, let us go to the next one. A point is called a point when it is just a geometric point. It's called a vertex when it is actually a point that is can appear on your screen. An edge is what you call a line, a one-dimensional curve, which has a beginning point and has an end point. It is an edge when it can be visually displayed. It's a curve when it is just the idea. A wire is one-dimensional and is a set of connected curves. That would be a simply connected curve in your mathematics, what you call a wire, but it is something that can be displayed. A face is a surface bounded by closed wires. So once you have a closed wire, you have a face. If a wire is not closed, it cannot form a face. And some of you might have found out when you try to extrude a drawing that has not been closed. It must be a closed wire for it to. You see errors like the wire is not closed. As long as the wire is not closed, there are certain operations that will not work. A shell is a two-dimensional set of connected surfaces, and a solid is a three-dimensional object that contains a closed bounded volume, closed by that are bounded by shells. So, in the 10 minutes left, because I want to close this class at 11:45. In the 10 minutes left, I'm giving you two assignments. Remember, these assignments are due December 31, 2025. So don't carry this assignment to next year. In this assignment start by giving you some code again. In this code, I'm not going to give you this code you are not going to download this code. You are just going to see them here or on your slides. I will send the slides to you. So in this particular one, run this code and you will see how we use a list comprehension to create 10 cylinders. There will be 10 cylinders that will be created because of this single statement. And then those cylinders will be displayed. They will be displayed. This is the idea of what the cylinder should look like, and this is actual cylinders that can be displayed. So you can see that anytime something is going to be displayed, you will see a part feature and you will see the name that will be attached to it. So that is what you are going to get in this particular situation. So the first step for this homework is to type this code in and run it. Get your result. After you have got your result, you study the use of a list comprehension, which is line 9 to 10. Just try to understand it and try to recreate the same effect using a loop. Try to use a looping statement to create the same thing. So you replace what is happening in lines 9 and 10 with a loop. If you can use that, you have done half of the work. So use a different mode. Then instead of making cylinders now, you are going to make some other objects, any object. If you like, make spheres. If you like, make any other thing. If you like, make toroids. If you like, make boxes. But they will all be different dimensions. You are submitting through your class rep. Yes, you submit through your class rep. December 31, 2025. So let me go to the second assignment so that I can release you for your test. In the second assignment, a toy maker wants you to create 1 million toys, wants to create 1 million toys for children this Christmas. As the design engineer in the company, you are to lead the production. Following the example of the groove on page 12 of today's lecture, write a macro to make a mold of the pierced solid sphere. Let this code be well annotated and own it. Even though you are copying from the code that I've given you, try and put some of your own imprint on that code. Again, the due date is December 31st. So this is assignment 2. So the next assignment you will get will be assignment 3. So by the end of the course, you might have gotten up to 10 to 15 assignments. Not only do you submit your assignments, you bring the assignments to the exam. Because usually the way I ask questions in this course is that you are just going to modify some of the things you submitted in your assignments so that those people who are doing the assignment will do well in the exam. Let me tell you, if pass mark is 40 and the exam and during the term, we have 40 marks for the continuous assessment and you have got 35 over 40, like somebody did this last term. The person got 35 over 40 and he got 2 over 60 in the final exam. What I try to do in the final exam is to check whether you indeed did your homework. If you do not do your homework and you are copying from others, you will fail the exam. If you did your homework, you will do best in the exam. Somebody who has submitted homework and has got 35 over 40 in the continuous assessment ought to get 80%. If after you have gotten 35 over 40 in the continuous assessment and you get 2 over 60, I know what has happened. You don't need to tell me. I know that you just copied somebody else's or some other people's work and submitted. And there is no way I can run after you. I don't have SSS, I don't have police. But the way I catch you is that when I ask you the same questions to just make some simple modification. For example, let me just give you an example of what I can ask in a final exam. You see this picture here. You see that this picture contains 3 circles. Suppose I just say, tilt the middle circle a little bit. Rewrite the code to tilt the middle circle a little bit. If you actually did this during the homework, during the term, and you played with it and you understood it, it won't take you more than 5 minutes to tilt that circle because you will know that all that you will need to change is the third vector, and you just need to tilt it a little bit. I can tell you which direction to tilt it, and you will do it. But if you just copied and you never studied it, you are going to be in trouble. So it is a good practice to start at the beginning now to be doing your homework by yourself. It is nearly 11:40. I want to release you early because some people told me you have a test, and I know that the people are not participating much because of the test. So I wish you all the best in your test, and Merry Christmas to all of you. Goodbye.